Perth Linux Users Group, talking Linux and open source.
Dropbear, so if you've used OpenWRT or DDWRT or any little embedded Linux things, that's the SSH client. So this is about him, and he's going to talk about it, so take it.
Evening, everyone. I'm Matt, as you said. I'm from Perth and been using Linux for a while. I've shown up to plug a while ago, but haven't seen people for a long time. SSH there's about 10% of the market share is Dropbear, at least that I can see. So that is about 2 million servers on the internet. If you go and port scan the internet, you'll find 2 million hosts running Dropbear. It's mainly used in small systems, so routers, things like that. But for all intents and purposes, it looks the same as normal OpenSSH. You log into it, you get a shell, and that's what people care about. I assume most people use SSH. Has anyone not used SSH but uses Linux? No hands? I assume so. So pretty much everyone has used SSH. I don't know, probably about 100 implementations of it, but for Windows, little embedded things, that don't even have an OS really, and then there's also, Palm top things and various other ones. But the main ones are the main implementations are OpenSSH, which is the biggest one, and then PuTTY uses, it probably has, I don't know, 80% of Windows usage, I'd guess. And then there's a few commercial ones which, people use for various reasons. Those ones often have, batch features and logging and things like that, which are useful. So I'll give a bit of a rundown of where people are using Dropbear. The biggest use is things like this, which is a wireless router. Usually, you'd expect maybe 8 megabytes of flash and, well, 64, 128 megs of RAM these days, though it could be, getting quite a lot smaller, 32 megs, 16 smaller. Usually, if you buy one off the shelf, it's not going to be running Dropbear. It's going to be having some funny web server, and you'll configure it and poke around there. But if you want to put your own stuff on it, you'll put something like OpenWRT on it. So that's a smallish Linux distribution, and they've got images for, I don't know, there must be a few hundred different devices that you can install it on. So the default SSH server there is Dropbear. I don't know that it's enabled by default, but if you want to log in and get a command shell, then that's what you'd be using. So usually it's fairly technical people installing those. You wouldn't just get one from the supermarket or whatever like you might with the normal router. Maybe not supermarket. Higher end sort of devices, things like Ubiquiti, higher end in terms of pricing and already configured setup, they're also running OpenWRT, and so those are also running Dropbear. I guess this is what you would usually interface with something like that. You'd possibly running PuTTY on Windows, a standard setup, and you see your OpenWRT login. I think for quite a few people that's the first thing they would encounter with Linux. They're usually using Windows or something else, but you want to change something, customize it, then you might have to log into a system like that. Puzzled looks. I will note that OpenWRT seem to have changed their name recently to Lead and forked off, but who knows what will happen with that in the near future. Another use of it, which probably actually accounts for a large number of installed systems that I don't know about, are servers. So first came across this at work. We had a cluster of servers, Supermicro ones, and I was poking around on the network, and I think I logged into the wrong machine, the RPMI interface, and said, what's this thing on our network running Dropbear? And we turned out we had 1,000 of them or so, which it just came off the shelf pre-installed. So for the management interface for a lot of servers, you can log in, reboot it, take screenshots, whatever, and those are often running a separate little MIPS ARM board or something like that, and that will be running Dropbear. You can't actually do much with these ones, but some of them are a bit more useful. Other things I've seen are Bitcoin miners, big clusters of them, which they base it on some small image because really all they care about is the little ASIC chip that's mining away, and then they just have some small Linux distro on top of it. Also, Debian uses Dropbear a bit for if you set up an init RAMFS, you can use that to log into a system and set up things before it actually boots. And if you want to log in securely, then SSH is needed. So that's another common use of Dropbear. Also, OpenBMC, it's kind of a replacement for the IPMI managements. I think some of the OpenBMC implementations are using Dropbear. Some are using OpenSSH, I'm not quite sure. Another similar use, the dropbear.nl mirror. I decided that, well, I've got a website, but its reliability was getting towards 1.9 for a month, so I thought I needed a mirror somewhere. So a Raspberry Pi is co-located somewhere in the Netherlands. So they were offering free co-location. You post them your Raspberry Pi with an image, and they'll put it in a rack and give it a network, and it runs. So it's still running. It's been there about 5 years, I think. So it's running Raspbian, but the big thing was I wanted to be able to make sure if it fails, it's the other side of the world. It's a pain to get it fixed. They'll charge 20 euros to reinstall it, and I don't want that. So that's actually booting an OpenWRT image that just runs Dropbear. So I can, once a year or whenever I have to reboot it, I can log into it. Then if I have a new kernel, I can upload a kernel, run kexec to boot that new kernel, and then I don't have to worry about putting a wrong image on /boot and it not working or anything like that, because it's all sort of a immutable main system image using OpenWRT, and then from that it boots onto the main thing. And it also means I can have an encrypted disk, so if a disk fails, I say, oh, I don't know, do what you want with it and things like that. So it works quite well. And I've also got an AVR stuck inside it to reboot it if nothing pokes it. Something has to log in every day to make sure that it still is actually reachable. So that's been quite robust. Another big use is for development. So there's all kinds of embedded Linux systems going everywhere. A few of the ones I've seen are train control systems, distributed clocks. They want very accurate clocks for some reason. Building management for the lights and power and aircon and all that. Power line control, VoIP boxes, modems, firewalls, all those boring things. So they're usually using some sort of based on a reference design from the microcontroller manufacturer, some MIPS or ARM, or maybe something a bit less common. And so they have a Linux distribution that basically just has the bits that it needs. So it'll have maybe a firewall, maybe some bits to control the pins that it needs, some network things, maybe some audio, things like that. So the common platforms for that are Yocto, which is quite a customizable thing. It has a set of packages that you say what you want, set how you want, type bitbake, I think, something like that, and it'll build your image. And there's Buildroot, which kind of is related to microlibc, and that one is a similar thing. You run a thing that looks like a Linux kernel configurator, say I want this package, I want NTP, I want this, that, and it spits out an image, and then you can use that. So Dropbear is quite commonly used in them, and then there's also the vendor tool chains. So I know TI, for example, I think use Yocto. They've customized their own version and say, okay, here you are, just if you want Linux on our device, just ship this and you're right. And also, so sometimes they're used for, in actual deployment. So, they need to be able to update the devices that have been installed in traffic lights or whatever. So they might use, SFTP into that and put an update. But a lot of the time, I think they're just used for development. So, while it's under development, you want to run GDB or something like that, you can SSH into it. But once it's deployed, it probably won't be running Dropbear. It depends a bit. There's 14,000 tarballs downloaded with wget each month. So I can only guess who's using them, but I assume people downloading source like that are probably using Buildroot or something like that. There's also things like universities with, I think this is a some sort of robot that drives around and to test swarming behaviour, or lots and lots of little things like that with gum sticks. And it's quite interesting. Occasionally I'll grep through the logs for the month and see what domain names have been downloading it. You go, oh wow, there's people doing this interesting thing. So there's lots of interesting Linux users which you sort of don't really know about, but it's interesting to see. And there's also devices that probably shouldn't be running Dropbear. So here's some sort of industrial control system mod bus that they customized Dropbear a bit too much and turned off the authentication. So you could just log straight in. That wasn't it. And there have been quite a few. I think a month or so back there was one. I know the password was, I don't know, login or something like that. And anyway, and there's also, they'll ship the same image all with the same host key, which it got a lot of media saying, oh no, people are using the same host key, but no one's ever going to log into those with SSH. It's a modem shipped by an ISP. Maybe if it has a bad password, yeah, it might matter, but people, media report things that don't really matter. So this was my original platform for Dropbear. It was a compact concerto. You can see here is a tablet, with a battery-powered tablet, a detachable keyboard. It's a PS2 keyboard you can unplug, so it's like a Surface Pro from 1993. I got it at Leadville Swap Meet. I think it was part of some e-health thing or something from hospital. So the specs were pretty low. It had 4 megs of RAM and couldn't go any more. No hard disk, so no swap. And it booted off a single floppy. And I was using it I was trying to connect to WA Freenet from my house. So had to connect up to, I had an antenna up on the roof and didn't want to bother running cables down. So I had 2 PCMCIA cards and bounced through wireless up to the antenna, and then it worked. But I thought, I was over wireless, so I don't want to be doing it insecurely. Can I put an SSH server? I tried to open SSH, too big. So I thought, oh, how hard can it be to write my own? And that's what happened. Sorry. So that was 2002. It was around exam time, and I had mild glandular fever, so I didn't have exams and couldn't do anything, so I was at home, but not that sick, so got lots of work done. So it was released in early April, the first public release, and by the end of the year it was, there were a few people using it in various small distributions. I think Leaf was a Linux. There was a single floppy Linux router type thing that was quite common. Lots of things using BusyBox and microlibc, which that was also, having quite a lot of development around that time. I guess devices, small devices were getting powerful enough to run Linux easily then, and also wireless devices were becoming more common. So, you want to encrypt things more if it's running over wireless. I was tossing up whether to use C++ at the time, but I didn't know too much about things like that. I think I was second year uni, a 20-year-old, and so I thought, I don't know. I tried a bit and couldn't get it small enough. So I thought, oh well, I'll use C. So it worked okay. It was probably a good idea. Learnt quite a lot about network programming, which that's a nice thing to learn about. It's fairly straightforward, and makes sense. And then Unix portability, which isn't so nice. The general C programming, network programming, that's all okay, but once you get into terminals and process groups and logins with Shadow and other things and TTYs and all that, it's all a bit horrible. But the Uni Computer Club had, I don't know, I think there was like IRIX, HPUX, AIX, a bunch of other strange, unusual distributions. I don't know if I got it working on a B-box, but so there were various things, and so I could try them out and eventually got them all working with a lot of, to this day the PTY login code is mostly just taken from OpenSSH because no point reinventing the wheel. The version number, it started at 0.28 and carried on until I think it was 2011, and then I decided, well, may as well make it actually a more than 0 point something release, and so I thought, well, a year would be a good thing to put in, because I could tell how old the version is and say, why don't you go and upgrade when people report things, which has worked well. And it's just a simple incrementing number. No point with something more complicated. I'm not going to spend too much time making stable releases and all kinds of things. If someone wants to, then that's fine, but it's a single person project mostly, so you might as well keep it simple. So in terms of development, I'm using Mercurial for the source tree. It was originally CVS, then went to monotone. I was involved in some monotone development. That was before Git. There was monotone, and that was quite a nice project, but it was a bit too slow and a bit clunky in some ways, so people didn't use it too much after Git appeared. And Mercurial appeared simultaneously with Git. It's a lot nicer syntax to use, and you type something and it probably does what you think it will. So. But GitHub has one, so I've got a mirror there, and people send pull requests and I can merge them, and that all works okay. There are a few hundred people on the mailing list. I guess it probably has, I don't know, a couple of posts a week, probably. So there's quite a lot of people who are just reading it and probably subscribing for updates. And then there are a few people who, people who've been involved with BusyBox and things like that, who'll pipe up if someone has a question, or their deep old Unix technical knowledge, which is sometimes useful. So most of the contributions, or I guess in the changelog at the moment, I'd make up about half of it, and then the rest are just assorted people. Someone will come along and have 20 different patches to fix something up, and then not be seen, and then a few years later something else. So it's quite a wide range of people. Mostly, someone sees something wrong, fixes it, sends in a patch, and that's it, which it works quite well. I've been quite impressed by some of the contributions, just how well they've debugged problems, jumping into a new code base. I sort of wonder how much time they've spent behind the scenes actually getting them to work. I guess one thing is, since it's a build from source thing, then it's quite a technical audience. Speaking to the OpenSSH developers, they get a lot more sort of, how do I do this? Oh no, it's not working, and not understanding anything because it's this thing that's already installed. So I guess that's one nice thing from my perspective. So each year there's a few releases. Well, it's up to 67 from 28, so yeah, you can add that up. So people would ask, why not use OpenSSH? Well, I think the biggest reason isn't actually the size, it's that it's less effort. Because if you're using OpenSSH, you have to use OpenSSL, which OpenSSL, well, I guess it's had a bit of a bad rep recently, but it's probably not too bad in terms of the cryptography bits are all a separate thing, and the SSL bits are their own thing. And OpenSSH doesn't actually use the SSL bits at all, just uses the crypto. And the crypto, it's fairly solid. It's very fast, faster than what Dropbear uses. But the big thing is, you install a version of OpenSSL, and then you have to match your headers with that, and you can't put a new version, and it's all quite messy. Whereas Dropbear, it bundles, well, if you want them, you can have your maths library and the crypto library bundled with it, so you just, the only external thing is zlib, which is pretty stable. Hang on. The other advantage is small code size. So SSH itself has a huge number of options for different ciphers, and each year there've probably been 2 or 3 more added, probably, I guess. You can strip it down to have one cipher, one hash, and just RSA, and that'll probably get away with talking to most servers, until some people are turning off SHA-1 these days. A bit of a problem. So, and then if you turn off those options, they also won't be built in the crypto library, and so it can cut down the size quite a lot. So to configure that, this is a snippet of the source tree. So you say, okay, do I want netcat mode? Yes or no? Do I want the algorithm list? Do I want AES, 3S, blowfish, whatever, for your reasons? And so there's a whole list of them. I've recently changed it so you only say what things you want to change from default. So it's a bit, this is the list of what you can choose, and there's a single file. You say which options you want in your build. And so that will shrink it down quite a lot. A typical size would be 150 kilobytes, I think, that was a MIPS OpenWRT system I was looking at, and that was shared linking. On x86, I think you can get it down to about 110 kilobytes statically linked to microlibc or something, so that's reasonably small. I would guess that if you really tried, you could probably get it, you could do an SSH implementation in, I don't know, 40 kilobytes or something, probably, if you really tried, but I don't know, I haven't. So being in plain C helps. Exception unwinding and things like that in C++ would be a problem for code size. And also, there's a lot of stuff that gets included that you don't really need, so linker flags can help with that. It depends on your compiler and what distro you're using. Static linking, I was surprised, but recently someone had, they statically linked, and that was actually smaller. I think their symbol tables were giant or something. So if you're sharing if there's a program that is going to be using the same libraries as a bunch of other programs, you may as well link it as a shared thing. But if it's just a single Dropbear binary and nothing else running there, then it may as well just be a statically linked. And this is how I, was cutting down the size of it. Basically, figure out what the functions are in it. That will look for the text symbols, so those are the functions. You can also look for tables and things like that, and just sort by how big they are, and then going through and have a look at the output of what any of those are doing, and if one of them's too big, then try and get rid of it or shrink it, and that actually worked quite well. I guess a big thing with writing a network-facing program is whether it's secure. I'm using C, which isn't too bad if you do things sensibly. If I wrote a new one, I wouldn't use C. I'd probably use Rust or something, or maybe Python, depending where. But it works reasonably. The biggest likely exploit is from use after free. So there's a second reference to it in some other structure, and then that one doesn't get set to null, and so something uses it, and you end up running code that someone has. There have been one or two, I think, of the exploits like that, those after authentication. I don't use pointer arithmetic. Instead, I've got functions which, you go buff read 10. So I've got a buffer structure, and all accesses to memory buffers are using that rather than using pointers. Or they can return a pointer if they need, but you say how many bytes you're getting out of your buffer, and I've written this many into it, I've read this many, and if you have too many in or out, then it'll exit saying bad buffer read or something like that. That's quite a common sort of pattern for if something unexpected happens, just exit. There's no point trying to fix it up and guess, because that's where you end up getting exploits happening. In terms of packet sizes and stuff like that, if anything gets over about 1 billion bytes, then it'll exit usually. That avoids thinking about overflows of 32 bits. I've had a few cases where there've been bugs in the program, as usual, and they haven't been exploitable because in general in functions I've always said blah pointer, I'm going to use it later, but set it to null before using it. And that has definitely caught quite a few things. So if anyone's writing secure programs, do that. Covariety is a static analyzer that will check your program for various problems. That's for open source, it costs quite a lot of money, I think, but for open source projects, you submit it, you can hook it up to Travis, so every time you do a build on a certain branch, they'll go through, they'll scan for any problems that they can see, reusing things after they've been freed, or passing things around, or bad checks or overflows, and it catches things. It's useful. I've had Clockwork was another good one that ran that, and HP Fortify had one that was entirely false positives, so I would not recommend that one. Completely full of them. It doesn't have privilege separation yet. Dropbear doesn't. So OpenSSH, their design is there's a network handling bit that runs as, I think, a separate user, or maybe as your own user, and then there's the core bit that can switch users, that can read private files, things like that, and that runs as root, but that's a lot smaller. I'm intending to implement that, but when I get to it. the general program structure is when someone connects to port 22, it spawns off a new process, and that process is responsible for all of that connection. I have wondered about making it a single process for the whole thing, though there's a couple of problems with that. One is that it wouldn't be as robust, so I can't use the exit on error handling as much. And also, when you're doing a key exchange or something like that, particularly on a slow device, it could take 10 seconds to calculate a RSA operation or something like that, and that doesn't really work if you're running all in a single thread. I could use threads, but that adds complexity too. So it's a basic select loop, and because there's there's port forwards happening, there's all kinds of different. There's the main connection, and there's shells and all different things happening. So I just have a select loop that looks for what has data to send or receive, and then calls function to handle each of them. It's fairly standard design. It's designed assuming that it's running on a POSIX system. So there have been a few people have ported it to little real-time operating systems and things like that. None of them that I know of have been made open source, I think. In part because they're a bit of a hack, so they wouldn't really want to, and also, some of them, they're commercial ones, so they're not too keen on it. Dropbear's MIT license, so people can do what they want with it, which I think I possibly get more people, mailing the list and things like that because of that. I don't know if it was a GPL one, they might say, oh, we're using it internally, but we don't want to talk about it. Whereas MIT, then, people realise, well, it's do what they want with it. So I'm not trying to sell it. If I was trying to sell it, then GPL might be useful, but it's just a project put out there. MIT license works quite well. And I'm using autocomp, so just a configure script. It's every time I sort of jump in and try to change it, I go, this is horrible. But I then thought, well, it'd be even more horrible to go through the effort to change it to something else. So that's all right. So the first thing to know about SSH is that it's unrelated to SSL. Lots and lots of people think that they're related, but they're not. They've got two letters the same in their name. SSH1 was, I think, 1995. It was one guy in Finland, I think, wrote it. And so that was under a fairly open license for a while and then became closed. So that's SSH.com, or Tectia is the company who sell that now. So SSH2 was from, 1998, but I think it took a while to get going. So, a couple of years before Dropbear started was when it became common. So Dropbear never bothered with SSH version 1. OpenSSH have almost got rid of it. They're going to get rid of it in the next release, I think. It's quite nicely documented. I think having a single person designing it, or at least the initial protocol, made it quite a nice thing. It's easily understandable. You can read it, compare it with some other internet specifications. The SSH specifications are quite nice. So you have a single TCP socket, and then it splits that into its own packets, and there's different packet types. I'll show you in a minute a diagram of that. So it can interleave, different, can send data packets and opening new channel packets and things like that all over a single TCP connection, and that, I guess, is what gives it so much flexibility. You've got something like Telnet, which, it's only a single connection going through, as far as I know. But SSH, you can have, port forwards, X forwards, agent forwards, or you can build your own things on top of it as well. So that is one reason SSH has been so popular. So the basic, here's an example of the interleaving. So say we've got someone who is typing ls/etc. Sorry, it's a bit small. And there's also the same, this is a single SSH connection through the internet. And someone's also doing a port forward. Their web browser has said get HTTP something. So in the TCP stream, it's split into two packets. One says, okay, this packet type is data for channel 1, and the payload of it is that red bit. So that's the actual data being sent. And then the next one will be another packet similarly. And so it's just interleaving those little chunks of packets. Each of them has a checksum at the end. I'll talk about that later. And the whole thing is encrypted, including the length, depending on the mode. So the types of channels you can get, actually left one of these off. The first type that should be right up here is a shell. So you can open as many as you want. You say either, give me a shell, you type on it, and it opens a PTY. So you get, key codes, and you can turn off echoing and all things like that. Or it could just be one without a PTY, which is usually just run a program, something like SFTP, which is another program, or you can run a command. And you can run as many of them as you want over a session. And then there's TCP forwarding, which I'll give an example of that later. X forwarding, so you log into a remote machine and your X terms and things like that come back over the SSH connection. Agent forwarding, that I'll talk about for public key authentication. And then there's, SFTP, that's just a normal process launched on the other side, and then it sends its own protocol again inside the SSH connection. Or you can do SSH inside SSH. So if I'm on my local network, I don't know, maybe at work or something, or we can't get anywhere on that, but pretend somewhere a bit less restrictive. You say, okay, I want to get to IRC, and I can't. So you say, okay, SSH to a local port, and this is what then your SSH program will listen on this port. Then when anyone connects to that, it'll hop on to that host and port through this machine. So then you can just run IRC, an IRC client on your local machine, and then magically out from dropbear.nl, the remote host, it makes a connection out to the IRC server. And then the reverse will also work, which is useful if you want to test scripts and things like that. So that's listening on a port on the remote machine. One unique feature of Dropbear is multi-hop. So often you've got, you can only hop through one machine to, there's a firewall machine or something you have to go through, and you want to transfer a file or something. You say, oh, I have to copy it to the firewall machine and then copy it to my own machine. What a hassle. So instead, you just put commas under all the things. So it'll split it up, and first it makes a connection to the first machine and says, give me a port forward to the next machine. Then it connects to that port forward, and which will end up on this one, says, give me a connection to the next machine, and so on. And so then you end up with a connection that is direct from your machine to the one at the end, and you can copy the file over. So it's quite a useful thing. And none of the steps, so this first machine can't see what the traffic is to the next machine, and so on. So if you don't trust the machine, well, it's not going to see password. It's encrypted the same as a normal SSH connection. Another big use of SSH is for file transfers. SCP is RCP. They just replaced a letter, basically. The code looks like it too. SFTP, you sort of look at that and you look at the NFS v4 spec and say, wow, it's an entire file system. At least the later revisions of it, it has everything, file locking, partial write locks, and all kinds of things. OpenSSH hasn't implemented all of that, and they don't think that's a good idea, so there's quite a split of SFTP versions. If you want to transfer files, I usually just use rsync. It's simple and fast, and if you've already got it, it's going to be instant. I've got my own hack, which, if you look on my webpage, it's got it, which will, if you know about SSH agents, that makes a connection through through any SSH hosts you connect through, and you're logged in, say 3 hosts along. That's not using that multi-hop hack, and you say, I want this file, so you can run SSH exfer, and it will send it through that agent forward the whole way back to your local machine. So I haven't used it recently, but it was useful at one point. I should resurrect it. They've now got an extension mechanism for SSH agents. So. The secure bit of Dropbear or SSH is the cryptography. So when you make a session, it sets up new keys for the whole thing. So each side generates a random number and uses that to derive a key that is only ever used for that session. The key is used for a few things. It's used for encryption, which is so the contents won't be viewed. So there's different ciphers. AES is the most common. SHA-20 is a newer one. It's very fast. So I soon will be implementing that in Dropbear because particularly for slow little devices, then that's a useful one if they don't have hardware AES. And there's a few older ones, Blowfish 3DS, which people are tending to phase these out for slowness and security. And then there's, at each packet, no one can look at it, but you also don't want someone modifying it on the way. You're copying a file and someone changes it, then that's no good. Or you're sending commands and someone sends a different command. So an HMAC is basically, I guess lots of people would know about SHA-1-SUM and checksums and things like that. An HMAC is like that, but you can only generate that and verify it if you know the secret key. So there's a secret key as part of the main session keys that is used to make sure that only each side could be generating that authentication hash. And then the clients and servers have to know that they're talking to the end they think they are, not someone else. So usually, a server can tell that it's a client if they know their password, or you can use public key authentication, I'll talk about in a minute. And the server host keys are, the server has to prove that it's the same server that you connected to last time, so it can sign a bit of data that's related to that particular session, saying, okay, this is a signature on this session, and then the client verifies it and says that it's all okay, or puts up a big banner saying, oh no, host keys are wrong. The key exchange itself, I wasn't sure whether to put this up, but I think it's quite an elegant thing. I don't know how many people know how Diffie-Hellman works. If you have two sides and they want to generate a secret number and that they both know but no one seeing the exchange can do, they each pick a number, they each send G, which is a magic number, we'll assume there's properties to it, to the power of something and send it to the other side, and the same the other way. Then they raise that to their secret power, and they both end up with this number here. And no one else can figure out that unless you can do a logarithm. But you do it using modular arithmetic, and you can't do a logarithm quickly, so that's how they generate a secret number, or a private secret, shared secret. Elliptic curve Diffie-Hellman is a similar principle, but using a different number space, I think. Algorithms change in fashions. When the SSH spec was written, SHA-1 was the thing to use. The problem is that's becoming less secure, particularly for things like SSL certificates. But for SSH, it's not too bad. I'd advise against disabling it because lots of implementations still don't support it properly. So, then there's elliptic curve algorithms, which instead of using normal Diffie-Hellman, use elliptic curve ones, and they're a lot faster. So they're popular, especially for things like where Dropbear runs. But some people don't trust NIST because they're related to the NSA, and Edward Snowden has had lots of revelations about them. But there's other elliptic curve routines such as curve 25519, which pretty much everyone seems to trust. So AES, most people would be happy to use that, though cha-cha is faster. But so there's lots of different people say, oh, you want this set of hashes and things, but in general, the defaults are usually reasonable. The biggest thing, actually, I forgot to mention is for ciphers, the CBC modes shouldn't be used, but I think most implementations don't preference those. With SSH, the client gets to choose what to use in terms of algorithms, but only from the list of what the server supports. Just a few suggestions about security. The biggest thing, I think, is don't have bad passwords, because there's bots that'll just keep trying 10 passwords a second for as long as they can, and if it's a simple one, someone will figure it out. It doesn't have to be too complicated to stop an online attack like that. Fail to ban is a program worth looking at. It looks at your logs, and if an IP address keeps connecting too often and failing, then it'll just block them at the firewall. For the types of systems where Dropbear runs, they often don't have good random number generation, which, as we saw a few slides back, the first step of it, the whole cryptography, is generate a random number. So if that's no good, then you're going to have problems. There have been improvements to that in recent Linux kernels. So, for a while they were saying, we don't know if this is a secure way of getting, generating randomness, the timing of network packets coming in and things like that. They, basically sum them all together and assume that no one can see them all at once, so that's good enough. Which probably is, but for a while they were a bit paranoid about it and said, well, we don't quite know, so we won't include them, which, ended up that there were, headlines of, 100, well, actually, not 100,000 key hosts, but, a lot of keys that had been generated independently on devices that had the same key, so, obviously not very random. Public key authentication is worthwhile because keylog passwords are a common way of breaking into machines. The situations I've seen where servers have got hacked, keyloggers I think would be the number one thing. But the second most common thing where I've seen machines being hacked is they've stolen the SSH private key, the client auth key, so beware of that as well. You could have them on hardware tokens, but then you have to carry it around. Who uses SSH public keys? Lots of people. Okay, well, hardly worth talking about. Okay, everyone knows that. So in terms of future developments, well, there's the never-ending continuing with crypto algorithms, which, there's new ones being added. Some of them are, actually useful, like CHA-20. Some of them are, I just have to implement them because otherwise it won't work with other things. Privilege separation would be nice to implement, though requires quite a lot of writing code, but also tricky design of how to pass credentials from one process to another and things like that. Getting a better test suite is high on the priority list. At the moment, I've got build tests on Travis CI that try a few different configurations, but not too much. So running some testing and also interoperability with PuTTY, OpenSSH, a few other ones would be worthwhile. And fuzzing is one other good thing for security. So that's basically you generate random inputs and see what happens. AFL fuzz is a very commonly used one. Some people nodding. The way it works is it basically generates random input and it's instrumented the program so it can see when it gets to an if statement, does it go this way, does it go that? And then it changes the input a bit and says, have I made it go a different way in the program? And keeps changing the input until it's covered every little path that it can find. So there's examples of, you start with a random file that says hello and feed it to a PNG reader or something, and after a day or so, you'll end up with genuine PNG files, that genuine image files just by passing input through the program and looking what happens. So it's impressive. So I've ran that on Dropbear for a while. It found a couple of small things, but it's difficult to run on a network program, and also because you've got the state of the, it sets up encryption and then it runs through the sessions. There's quite a lot of work to do there. The OpenSSH developers are also working on, I think Damien Miller's set up, he's got something ready to run if he has a cluster of 10,000 machines, but he works at Google, so I assume he will soon. Also, I've wondered about, I've got myself, some little ESP8266, little wireless chips, for example. They don't really have an OS, but I think, it'd be nice if we could SSH to these. So that would basically involve turning Dropbear into a library as opposed to a separate program, and abstracting some of the authentication and things like that, which I don't know if we'll get around to it, but it could be worthwhile. One thing that probably is more likely to happen is rather than having something like PAM for authentication, or people doing their own custom look in a file to look up the usernames and things like that, just put in some Lua hooks. And Lua is a simple script, well, not that a nice embeddable scripting language, quite powerful. And so people could just write a script that say looks up a username from somewhere or things like that, rather than having to make modifications to the Dropbear binary itself, which I guess would be particularly useful for platforms where cross-compiling's a pain. If you can just write a script, it's a lot easier. So that's most of what I got to talk about. Does anyone have any ideas, suggestions, comments on Dropbear SSH in general? Anything else?
I saw you mentioned the fail to ban
Hmm.
script, which I have to speak at the microphone.
Hmm.
I saw you mentioned the fail to ban.
Yep.
And I know that something OpenSSH brought in sometime in the last decade was, sort of connection limiting, kind of like targeting. Is that better now?
Yep.
Where it was if it was receiving too many connections, then it would slow down the response rate to respond. It was just to stop the server being flooded. So I was just wondering if you were
Dropbear has something, I don't think it's quite as sophisticated. The question was, OpenSSH has something to stop flooding of connections so that it doesn't get flooded out by someone doing something bad. Dropbear has similar, it has limit per IP for connections. I think it's 3 unauthenticated connections per IP or something like that off the top of my head. It's not as sophisticated. I think OpenSSH is sort of probabilistic, so you'll eventually get through. But I sort of thought, well, if someone's got that many IPs, there's not much you can do about denial of service that way. So it didn't seem worth the complexity.
that was my only question.
Yep.
Just interested if you had any problems specifically to do with micro-C Linux or embedded devices versus programming just busy those lines.
Not too many. Are there any problems programming micro-C Linux and embedded platforms? Actually, sorry, micro-C Linux does have some limits. Sorry, I was thinking microlib-C. You have to run it out of inetDs because Dropbear isn't going to execute a separate process, so that they don't share the address space. You have to run out of inetD. Otherwise, I haven't had too many specific things. Slowness is one thing for some embedded platforms, particularly people running CPUs on FPGAs and CPUs with no cache and funny little things. But usually when I've pressed people, said, try to actually get to the bottom of what's the slow bit, then they don't respond or go elsewhere or something. So I don't know.
Okay, you mentioned that you're toying with the idea of running it on no operating system type devices. Would you consider, this is just an idea more than anything, would you consider perhaps running it on, say, a solar PV system, which you can only do Modbus on?
I don't know too much about Modbus. So what's the operating system on those sorts of?
Usually they don't really help. Some of them do have embedded Linux on, but if you could tap into the Modbus spec, perhaps you could use it on that.
So running over Modbus?
Yes. You get more secure connection directly to the Modbus.
Yeah, I suppose that.
Libraries, etc.
I haven't looked at that. Certainly can run over any stream-oriented thing, so yeah.
You're mentioning sort of compiling everything statically as well. For such security-conscious software like this, doesn't that sort of disable things like address space layout randomization? And
Yes, it does.
Right, you think that's a problem, and is it worth the trade-off there? Or?
It depends on what sort of system you're running. I guess a lot of the time it's people just compiling it just to run it on some embedded thing for development. In that case, no. But yeah, if it's a thing that's going to be widely deployed, then yes, it will you probably should run dynamically and with randomization.
Okay.
I suspect if it's a smaller, less known platform, then it's not going to have as many people attacking it. Yes, it's obscurity, but you are going to get less.
How many copies of Dropbear do you think there might be out there?
Data centers are the big unknown. I don't know. How many of Ubiquity sold of their devices? Ubiquity would be a big chunk. There's various ISPs have a few 100,000, so I don't know. Could be 10 million, but I don't know.
Wow.
Well, if you go to Shodan, the port scanning website, there's 2 million listed, but who knows what's behind networks and data centers. The actual amount in use is probably 1% of that. But
Anyone else? Any questions? I think we're done with questions for today. Thank you very much for coming, Matt. It was a pleasure. Really good talk. Thank you. All right. Cheers for Matt for coming. Thank you all for coming as well. We can't do this without you guys. So if you're not a member already, sign up online and get your account set up and everything. And also, we always forget to say this. If any of you or someone who's watching online is in the area and is interested in doing a talk, just contact us and we'll be happy to have you here. We really like getting local people and it's great. So thanks again for coming and thank you all as well. See ya.